All right, this is problem 7.7 from Brigham and Houston's Fundamentals of Financial Management, concise 9th edition. And in here we're asked to measure the interest rate sensitivity for 5 bonds. Each of the bonds has a par value of $1,000 and an 8% yield to maturity on purchase date. And then the problem says that immediately after the investor purchased them, interest rates fell, and then they had a new yield to maturity of 7%. And what's the percentage change in price for each of them? All right, I'm going to put the percentage changes up here so I can use cell references. The number of periods, the par value is the same on each of them, and then the payments. All right, so this has got 10 years to go. All right, so 10 years on the first one, 10 years on the second one, 5 years, 30 years, and then the perpetuity, this is infinity. So I'm going to solve that one differently. The par value is $1,000 on each of them. And the payment is $100 on the first one, 0, 0, 0 for the zero coupon bonds. And then when we look at the perpetuity, it had an 8% yield to maturity on the day it was selling, then the payment would have been $80. Okay? If you remember the perpetuity, present value equals rate, present value times rate equals PMT. So if the par value was $1,000 and it was yielding 8% on the day he bought it, then it means that the payment was $80 a year. Okay, so now we've got these numbers for each of these. If I want to solve for the price on the first bond, present value, the rate and I'm going to use the dollar sign to lock in row 5, the number of periods, and I'm going to put a dollar sign in front of the H to make sure the column doesn't change when I copy it over. The payment, it would be dollar sign J7. That would be this cell here, and the future value be dollar sign I7. Okay, so by using the dollar signs in here, I've set it up so that I can simply copy this over, and the only thing that'll move is instead of looking in cell D5 for the interest rate, it looks in cell E5. You can see that up here in the formula bar. The dollar sign in front of the row, in front of the column for H, I, and J keeps that from changing when I copy it over. The dollar sign in front of the row here means that when I copy it down, the row will stay the same, but now it's looking in this row for the data for this particular bond. And so I can copy all these down. For the perpetuity, I just take the present value, which here would have been $1,000, but if I take the payment, the dollar sign in front of it, and then divide it by 8%, it'll give me what the price was, and then when the interest rate drops, that's the new price on this bond. Alright, the percent change is the new price divided by the old price minus 1. And we can see that the price sensitivity differs between these bonds. If we look at the difference between a 10-year zero and a 10-year coupon bond, the higher the coupon, the less the sensitivity. You can't get lower coupon than zero, so zero coupon bonds tend to have greater sensitivity than coupon paying bonds. The only difference between the 10-year and the 5-year is maturity. So there's a bigger percentage change in the 10-year bond because the longer the maturity, the greater the sensitivity. Look how much the price changed on the 30-year zero coupon bond. All right, that's a huge change compared to the others. And then for the perpetuity, you see a change of about 14%.